Hello and welcome to Python for Data Science Beginner course. This lesson focuses on a very special data structure in Python, and that is the data series. We are going to look at how we can form series by selecting columns from the data frame. We can also form series when we select rows from our data frame, and these series have some very unique properties that allow us to ask very specific questions of the data frame data set and have it return us important answers. And so this we are going to begin by first loading in the modules or the libraries, the Python libraries that are built in that comes with the programming language, but we always have to load them into our Jupyter notebook as we're working here. So I run this cell and that loads in the NumPy as NP and the Pandas as PD. So whenever we need to use the NumPy, we'll use the NP abbreviation, and then we'll use PD for our Pandas. Pandas is the data frame, just like a spreadsheet. We can also use that PWD to give us an idea of where this particular notebook is saved on the computer. And now that I have pandas loaded, I can load the data set that I need. So the data is stored as comma separated values or as a CSV file. And using a method of pandas, I can read in that file. So that is going to go and read every line of my data set and read it in as one whole data frame, and then I assign it to the name df. So now I have my data frame loaded. I can use the .head method to look at the first 5 rows of the data. So I see here I have columns with the names, and this is fake data, the gender, age, education, all these features about the persons in the data set. And then the final column is an indication of whether that person suffered chronic or coronary heart disease or not. So if we want to see more of the data frame, we can see it like that. We just increase the number. So this is just a snapshot of our data. If we did the df.info, it gives us a full picture. So we have 4,200 entries, and we also have 17 columns, 4,240 entries. So that's what our data set looks like. And if we do .describe, we will see the basic statistics for all of the columns in the data set. So that's what we are working with. That is our data. And so we're going to use various Python methods to select specific columns in our data frame from our data frame and then be able to work with those. This is something that we do as data scientists. We have loads and loads of data. This is a small data set compared to some of the data sets that may contain thousands, if not millions, of observations for millions of people. If you think about the data that is being collected by social media or by Amazon or any other entity, it's going to be a very large data set. And so when we want to work with the data, we don't sometimes use the entire data set all at once because it can be computationally expensive. So we select portions of our data frame. So selecting from the data frame is something that happens very frequently. And so it's important to know how to do that. So we're going to be selecting from our data frame. So remember what our data frame looks like, and I'm going to move that down. I'm going to put it back to 5, and I'm going to use this to move the picture of the data frame down so we can see what it looks like. So we have all of these columns here, the names, the male, age, education, current smoker, and so on. And we if we want to select any one of these columns, there are several ways we can do that. And so one of the ways is to just do df dot the name of the column, and that will give us a series for the ages of all of the patients in our data frame. And now we're assigning it to a variable name sr1. So if I run this code, that's what's going to happen. So now I've created this series, and if I applied the type method, that would tell us what type of data structure it is. And see, it says pandas.core.series.series. So it is a pandas series. So that's one way to select a column. The other way we can select a column, similarly as we did when we were selecting from some of the other data structures like the list or the libraries, we can use the double square bracket. So we put the name of the column inside of the square bracket and we assign that to a variable. So here we also get a series. We can use either of those. The second one is preferred if the column name may have spaces or some other type of irregularity. And so just typing it after a dot may not actually work. So we use the square bracket in those cases. The third way that we can select a column from our data frame is using the loc method or the location method. And what that does, it is looking at the all of the names of the columns as a kind of a list, and it's then selecting from that list the name and then using that to find the data of interest. With the low column, though, it's important to realize that you can specify both the row and the columns. So the first item inside there, it identifies the rows, and the second one identified the column. So if we want all of the rows, we simply put the colon there followed by a comma and then the name of the column that we are interested in. So if we ran that, then we see we now have a third way of getting a series from a pandas column. So the next way that we can actually uh, do that, select out a column of data, is using double square brackets. The only difference is that when you use the double square brackets, instead of getting a series, you're actually getting a data frame. So if we were to run that type on the structure that we just created, we would see that it would indicate not a series like the others, but in fact, it would be a data frame. So that is how we would do that. But all of these now are all the series are one dimensional, whereas the the data frame, it's a two-dimensional structure. So just like our original data frame, if we looked at the printout of our df1, this is what it looks like. If we were to print out one of the series that we created, this is what it looks like. So essentially, it is the same in that you have a list of values that are being stored, and you also have an index or a marker that is identifying those values, and you can use those markers now to select from the series the actual value of interest. So you select the column, and then you can use the index to select one specific item. And that index in the series we see here, in this case, it's numbers, but as we'll see later on, it can be other text values. It can be names, it can be colors, it can be cities, so we can have a lot of different ways that we can use as indices for our series, as well as even for our data frames, that help us to do very fast lookup of our data, because that's something that we have to do commonly. So now that we've created our series in, or even the data frame, we can apply a number of series methods that would help us understand. So we know that series one is the age of all of the patients. If we applied the dot max, it would return the age, the oldest age in our data frame. If we did a dot min, it will tell us that the youngest person is 32, the oldest is 70, and if we wanted to, we could do other types of mathematical applications to the series of numbers. But we are now going to look at how we can form a series by using the iloc method. So the loc and the iloc are actually faster methods than just using the square brackets alone. But with the loc, this, or the locator, the it uses the actual names of the column or the names of the row if it's in text. The iloc, the I represents the index number. So you have to use numbers with the iloc. You can't use letters. So if we wanted to select from the data frame and we wanted to select the fifth, or the row or the column at index 5, this is how we would do that. We would simply do iloc followed by the square brackets, and that would give us the person or the patient that is at row at number 6, in this case, that row that is number indexed at 5. And so that's how we would use that, because remember, with the loc and the iloc, the first argument inside of the square brackets is referring to the row. The second one is referring to the columns. Now, if we don't put anything after the first number, the assumption is, the default is that we are selecting all of the columns and just that row. So that's how we would use the iloc. Now, if we wanted to take a look at what our we have for the age bracket, we did create that data frame before, and if we wanted, we can make changes to that data frame in terms of taking out certain values and keeping others. So now we're looking at how to select rows from our columns, and we saw that we can use the iloc method. So in this case, we have selected, if we increase this so we can see what we're looking at, and here we have selected the person or patient at the row that is indexed 5. And so we see we get the name, the gender, the age, and all of the values in another data structure. And if we wanted, we could actually do a type on that SR4, and we would see what that is. And we see it's a series. So you select a column, it's a series. You select a row, it's another series. So these are some of the main ways that these series are generated in Python. And then there are several methods, built-in methods, that allow us to do some really powerful computing and data analysis when we are working with these series. So now we have been using a data frame where the index is one of numbers. And I want to show you that you can also have index that are not numbers, but are some text. So we're going to do two things. We're going to show how we select several rows from our data frame, and then we're going to look at how to use this data frame now, where I change the index from numbers to letters. So we have here the code. We're going to select the first 100 values, 100 rows in our data set. So we see we have the df.iloc, we have our square brackets, and the first term before the comma is, it says just the colon 100. So that means I am selecting everything from 100 and above. And then I follow with a second colon, meaning I want all of the columns. So if we run that and we do dot shape on that structure, we see that it is 100 rows as well as 17 different columns. So now that we have that, we can take a look at our data. This is what it looks like. This is our smaller data frame now, df.100. And now what I'm going to do is I'm going to make the names as the index. So I'm using df.set underscore index, and I'm and identifying the column. So that column then becomes the new index. And here we see what that table looks like. So now that we have that, we can use these names to help us find different pieces of information from our data based on the names. So if we can use the iloc to select. We can still use iloc to select parts of the data set. So if we, for example, said -1 as far as the row is concerned, and then the colon for all of the columns, and we ran that, we see that it's giving us the information for the patient that is last on our row, and that is this patient, Sandy Sedberg. Now we notice it does not give us the name because the name is actually the index. So that's kind of just the identifier in this case. So we would probably assign this to some name, and then, or some ID number that will then be used to help us identify to whom this information belongs. If we want, we can do index.index, and that would return to us the if we did